Sam, welcome to the podcast.
Thank you very much. Still very happy to be here.
Thank you.
Yeah, gotta love technical
Okay, so
issues of remote working.
oh, it's always the way. So I'll start with a simple question. What are you most excited about working on at the moment?
Easy question, mate. The reason why we met 2 years ago, it's Ocean Bit. So we're trying to develop offshore renewable energy power plants with co-located data centers. Tackling two major demands of our time, which is energy scarcity and data scarcity.
Awesome. And for someone that doesn't
And
understand what
yeah,
any of that
I mean,
means, break down what those things are.
uh, we're going to have to make Pat work. I think just with the connection here, we've got a bit of a delay, so I'm going to try and hold back a couple of seconds before I start talking because I can see me talking over you. What does that mean? So OceanBit is trying to build an offshore power plant using ocean thermal energy conversion as the energy generation technology. So we're drawing deep cold water up to the surface. We're using that to condense a working fluid. We then evaporate that working fluid through surface water temperature, which is warmer. And that process of turning into a gas and generating pressure, we can push that through a turbine and extract energy. Then what we hold is some IP that links data center operation to that power generation process, so that we can utilize all of the electricity that we generate, as well as have an incredibly high efficiency. We also utilize all of the wastewater from that power generation as our excess cooling for the data center. So we're able to compete with regional on-land data center costs, and in some cases, or a lot of cases, beat the cost of hosting ashore.
Wow. And Sam, so tell me, so where the ocean thermal technology is not a new one necessarily, but what's cool about this idea is putting together technologies that couldn't previously be combined. So how long's ocean thermal been around as a concept, and is it a very popular form of energy production?
So it's a two-part on that one. So ocean thermal energy conversion in theory has been around for a really long time. Early 1900s, they had an example scientific proof of the theory, but it was the manufacturing support behind. So the production of the large pumps, the heat exchangers, and even the housing that didn't really exist at the time, that kind of restricted that being an opportune or a desired use of energy generation. Leapfrog to 2025, and we've got the oil and gas industry that have spent a significant amount of effort, time, smarts, money in developing systems to pump and move fluids and convert energy in the most efficient way, because their whole business is getting hydrocarbons ashore as cheap as possible. But that technology development is directly transferable to ocean thermal. Then the next hurdle was that computers, mainstream computers and general use data was not a thing 100 years ago, and really not a thing until really the AI boom just created this incredible demand for data center. Data center. I've lost the word completely. Thank you. The AI boom has created this incredible demand. Thank you. Yeah, data center infrastructure. And so that's this combination of the fact that we've got the equipment, materials, and theory have all been done before, but no one's built them together like we're trying to do it.
And so when you talk about deep water versus surface level water, how far down do you have to go to pull up the correct temperature water, and what parts of the world is this type of technology best used?
So the cold water portion, so we're targeting about 4.5 degrees Celsius. So generally speaking, that's between 900 and 1,000 meters. but there are some locations around the world that you can find that water around about the 750-meter depth. And what we need is it's actually the combination of that cold, deep water and the surface temperature. So the surface temperature needs to be warm. So you start at the equator, and we generally look in the area between 21 degrees north and 21 degrees south. So looking at the Pacific Islands, Southeast Asia, that's definitely where we're trying to kind of keep our attention to deploy first. But across the entire globe on the equator.
It's so cool. And shout out to Nate, who you work very closely with, of course, who actually came on Bitcoin with Jake a number of years ago. And we also had the pleasure of meeting him in Bali. The process of actually building a startup, like especially a hardware business that I assume this is, takes a long, long time. What have been the biggest challenges so far, Sam?
I think one massive learning that we had to kind of really come to terms with was that Nate started the company before I was in the picture, and so that was kind of 2022 region, and I met him soon after that. But startups had an incredible run in the 20s and the 21s. There was an incredible amount of money being invested, and so we thought that was phenomenal. We're going to start a business. We're going to access this funding, and off we go. We thought we were quite smart and going to be the next unicorn. And I don't say that with I guess any anger. It was more of a very great learning experience that all of a sudden we went, oh right, no, we're trying to build things that it's not a digital idea that can suddenly reach across the globe. We're actually trying to amass huge amounts of equipment, put it in a ship, sail that ship somewhere, connect it to a grid, connect it to a telecommunications line, supply humans with a service, and we went, right, this is a long haul, and so that was a nice learning experience. But it also showed, like we're here quite a few years later. I think we've made some incredible progress, and we've met some, yourself included, nice nod to the host, but we've met some incredible people along the way, and so where we are now is we've kind of confirmed our resolve to keep going, and we know it's not an overnight project. This is still years in the making, but every day is a step forward and a step more towards getting that first ship in the water.
And so what does the kind of first stage of prototype look like? And I asked that with the lens of an investor lens. Okay, some guys have an idea, taking the idea from idea stage to like, okay, we've actually proved this idea works, can actually be done in lots of different ways. You don't necessarily have to have the multi-million-dollar vessel that's doing all this stuff. What looks like a kind of first phase of prototype of this for you guys? And have you built it, and how's that gone down?
The discussion around a prototype is, I think, quite an interesting one, because what we're trying to do with OceanBit is we're trying to leverage the proof work that other people have done. And it's not so much a cop out, but it's very hard for Nate and I to justify someone to take money out of their pocket to build a barge or a small uneconomical demonstration plan, which was, one was built out of Korea in 2023. And, they launched it and they generated electricity. It was a demonstration plant, a 1 megawatt barge. Creso deployed a 1 megawatt ocean thermal barge, and it operated and it generated electricity. And so it's a bit hard for Nate and I to justify building another barge when we know the science works. We know the technology and the equipment that's out there is in operation in other areas, but we have use cases for the chemicals, the seawater, the mechanical gear, the pumps, the turbine. All of it exists in the world in some form. So we're not trying to build a new piece of equipment. We're just integrating something that's been demonstrated before with a data center. And the data centers, all over the world now, there are entities that are deploying demonstration data centers, either submerged, in the Bay of San Francisco, or building data centers on top of a canal so that they've got immediate access to significant amounts of cooling. And so we kind of use the counter. Well, the demonstrations are there. We just want to integrate something a bit more bigger and make it financially feasible, and something that is actually going to be in operation for 30 plus years, bring renewable baseload energy to a grid, and bring sustainable data center service. Some people kind of go, oh no, you need to make a demonstration. But when you look at the cost to build a barge and an ocean thermal plant that is not financially feasible, it doesn't really sit well with Nate and I to do that, when we can build something that is going to return money to investors and is going to provide a service to the local economy.
That's really cool, Sam. And I do love this idea of building on the shoulders of giants. And Bitcoin itself is a great example of that, right? It's not, oh, look, someone just invented peer-to-peer digital cash. It's like, no, there's been 40 to 50 years worth of computer science that's gone into this one moment where someone blended together a bunch of things and, of course, put their own twist on it. But what I'm intrigued about then is this idea of Bitcoin itself being it's decentralized, right? And it can use energy anywhere. So what does that mean? And also, you touched on that idea of baseload renewable power. So there's two questions. We'll do the baseload bit second, but being able to plug into a network that pays you anywhere in the world, what does that mean commercially?
It's an enabler. It's the customer that doesn't need a bunch of I guess business plans and customers and logistics planning and freighting and all of the things around transferring a tangible good. It's a ambiguous customer that only needs energy and doesn't need infrastructure. So you can kind of leverage having Bitcoin, a Bitcoin mine, as a first use case on an energy generation source to generate income while the industry builds out, because that energy's there. So I might try and rephrase that. What Bitcoin kind of enables with the remote power generation concept is that you can develop and start generating electrons, and you can sell them before the customers are actually there. So Bitcoin is an opportunist. So you deploy it where energy is abundant, and pretty much you're trying to find the cheapest energy out there. And that generally comes when there's not enough consumption at the generation. So taking remote hydro or a newly developed wind farm that's not fully integrated into the grid, those are locations that have excess energy that is available for consumption. And you can deploy Bitcoin without much infrastructure or really any kind of external forces. It can be an internally operated mechanism that uses those electrons to convert it to a currency. And look, we met because of Bitcoin, but you don't even have to hold the risk of Bitcoin. You can convert that into cash, and you can pretty much use it as a digital transfer from the effort mined Bitcoin on that abundant energy. You can convert it immediately to cash. A great example of that is Iron. That's kind of their operating MO. They don't hold Bitcoin as an asset. They convert it to cash, and they've made an incredibly successful business. And so, I look at Bitcoin as being an enabler that could be the missing gap that a lot of these remote resources or remote energy generation projects need to get over the line to survive until the industry appears.
And Sam, so tell me, do you think that it's, when I look at, for example, a big hydroelectric dam that has excess energy that's not selling, and therefore you can stick some Bitcoin miners on it and you can monetize stranded energy? That makes sense to me. But in some ways, you could argue that that's like fiat misallocation of capital. Do you think that there's going to be
Well,
opportunities for people to develop out and out um, kind of energy production on a more
mm,
decentralized level that's not a fiat misallocation? Does that make sense? So, like you guys, obviously, you want to
yeah,
get a barge up and running doing ocean thermal.
I'll kick off on that response because it's I
Please.
think it's a really interesting crossover because I guess this is one thing that I've kind of expanded my view a bit of what we're doing as Ocean Bit, and then also what Bitcoin mining has enabled globally, and not just as a I guess a pivot to be Bitcoin maxi, and we need to you know deplete fiat at all costs. But and not to say that's what you were going for, but converting to fiat actually can achieve, I guess, not such an economic driver, but maybe a social or a kind of a locally beneficial impact. So, it, unfortunately, I'm horrible with names, but I know in cases in South Africa, there's a hydro farm that they installed a bunch of Bitcoin mines attached to it, and the Bitcoin revenue has been able to cover the maintenance costs for the hydro and ensure that that hydro is supporting the local power grid more reliably. And so it's an enabler that, it's not just, put all of the Bitcoin mine there and only do that, make a lot of Bitcoin and hold on to that for the next 50 years, because we're not in a world that's sustainable yet. And so it's one of those things where I kind of go, well, okay, I guess what what made or what introduced Nate Knight was that I listened to him on a Bitcoin podcast, and it was phenomenally. He had this wonderful idea of having an independent floating vessel in the middle of the ocean mining Bitcoin on the largest natural resource of the earth, the ocean, and which is incredible. And had we built it 3 years ago, we'd be very happy startup entrepreneurs. But it's very difficult to finance that in a fiat world. And so where we actually realize that the Bitcoin integration into an ocean bit asset is actually filling the gap, where we're looking at supporting a local grid. We're looking at having a data center aspect because there is so much demand, and we have a solution for data centers that are constrained in city centers, and they're getting boxed out due to land, electricity, and water. We've got a solution for that, and then we've also got space for Bitcoin to consume the middle ground to make sure that our asset is consistently generating income to ensure that the investors and the partners that we bring on for a project are sufficiently repaid, so that asset is something that comes down as a business plan. So it's an enabler that allows that final part of the financial feasible
And
mix
and
to
so
be
in some
satisfied.
ways then you can think of ocean thermal and a barge as like a windmill, and you're taking the energy production capacity of the ocean and running that through a turbine.
You're right. It's our ocean thermal energy generator is is targeting these locations along the equator, which, funnily enough, using your example there, really don't have enough wind resource to be suitable for wind farms. And when you're looking
Okay.
at small island nations, they are landlocked. They can't be sacrificing 70% of their land for a solar farm. And I apologize to
Mm.
solar enthusiasts. That's not meant to degrade the benefits of solar around, but more of just a physical restriction for the islands.
With like, ethanol and biofuels, the discussion is food versus fuel. And so, if you are squeezed for space, like an island nation would be, then dedicating area that could be food to fuel is a trade off that's perhaps too big. And then, of course, like being able to plug into an offshore rig that's using renewably sourced energy from ocean thermal, I mean, that would be an incredible piece of technology for island nations. Um, why doesn't that already exist as an independent kind of energy infrastructure that's like it's too expensive, I guess, or
Well, that's yeah. So, and that's what I guess Nate loves this topic because ocean thermal is a big topic of Hawaii, another Pacific island that is landlocked and is really suitable for ocean thermal. But the I guess it was an uphill battle. I guess the advent of the internal combustion engine, gas turbines, and the abundance of oil and gas across the world. It was a lower capital cost to build a generator for an internal combustion engine. And if you
mm,
don't need the electricity, then you don't burn fuel. But now we're at a point in time where not only, with ocean thermal, not only is renewable energy such a supported concept, but at that kind of mixing point of the data centers are gridlocked. They're restricted on electricity, on water, on real estate, and so where OceanBit really finds, I guess, the economic value of ocean thermal is that we can build this now with established manufacturing processes. So, sorry, I was kind of going a bit off topic there, but that's really where 50, 60 years ago, the manufacturing was not there to support the size of equipment at that time. So we're talking huge water pumps, huge heat exchangers, a large turbine. Technology has advanced because of other demands, which has then made ocean thermal a viable solution because the equipment has been developed. So the cost of all of the components has dropped dramatically in the last 15 years.
mm. It's very cool. And it makes me think, Sam, as well, about your comment
Yeah.
earlier on baseload power. Maybe you could help to unpack what that means for people.
Sure. So it's a definition of, I guess, your grid electricity, which is the underwriting stable chunk. So in Australia, baseload's a great topic because it was really kind of dug into about we need coal generation because that's our baseload underwriting the grid stability. So baseload is essentially a consistent um, amount of energy present to the grid that can be consumed. Where if you look at intermittents like solar and wind, they come up and down in a cyclical fashion. And so
Yeah,
where
cool.
where I guess you look at your diesel and coal generation as baseload functions. Diesel's a fast response and coal's a slow response. And ocean thermal without the data center integration is a slow response baseload. But what our IP brings in is that we actually are able to balance the two parties and create a constant baseload into a grid that is equivalent to a dispatchable load as well. What that means is the grid can demand and pull energy from our generator with short notice.
Yeah, so and forgive me for anyone who's listened to my podcast in the past, but one of the dots that was crucial for me on the road to like, oh my God, Bitcoin's a big deal, I must learn more about it, was the energy piece. And I had tried to found a
Mm.
energy startup in the UK, and we were looking at the demand side response market and how could we help individual retail customers in their homes reduce their energy consumption at certain times of day using behavioral economics and an app that we were building. and it didn't go anywhere as a concept. We almost got some grant funding and it failed. But what it taught me was like a lot about how energy grids actually function. And so when I realized that Bitcoin mining was this piece that could slot in and balance the difference between now
Yeah.
all of this intermittent power production that's coming online, the solar, the wind, our energy infrastructure in terms of national grids are not built for that stuff. Full stop. And so being able to
Mm.
integrate it more
Yep.
efficiently is a massive, massive, massive deal. And so what you've kind of just described there in my mind is the ability to reduce the amount of demand on the grid is valuable to the people operating the electricity grid. So if you're running a whole load of these vessels
Yes.
offshore somewhere, supplying a load of energy, and they're like, guys, we don't need all this energy right now because the solar's pumping or the wind's pumping. It's like, cool, we're just going to sell it to the Bitcoin market. And you have a way
Yep.
of playing both markets so that the grid would pay you to reduce your demand, and then the Bitcoin network would also pay you for supplying cheap energy. And it just makes the whole electricity production system much more efficient. And that for me was just one of those key pieces that like this isn't like spooky, internet money or a token that's spun up in Malta and shifted to people on Telegram groups. This is like a massive deal in how we produce energy. And as you talk
Yep.
about this idea, it's like, hang on, I'd only ever thought of nuclear as a probably long-term baseload renewable power. And now you've revealed this to me from that viewpoint as well, because I hadn't thought about it as a baseload. Very, very cool, Sam.
I look, and that's along the journey, just learning how these assets actually bring so much value to the grid. But it's actually that's another great segue to go back to why not build a demonstration plant? Well, the
Sure.
ERCOT, the Texan power grid, is an incredible example of how controlling data processes can actually provide benefit to the entire grid and support the stability.
Okay.
There's I think
How does that work?
between
Teach us how that works.
well, and I apologize for the specialists out there. This is the generalist interpretation,
No,
but
please.
yeah, perfect. So, in general terms, the grid sends out to demand status every 15 minutes, and the various kind of super consumers, like the large 100 megawatt data centers, and I think even some of the smaller ones, but they are able to regulate the processing of their compute. So they can kind of turn a simplistic dial and reduce the processing effort of all of their computers, which reduces the power consumption of their computers, which then responds to the ERCOT signal saying, well, hey, we need more electricity on the grid, or we've got too much, consume more. And it's the reverse. The data centers can then overclock and actually push the processing up higher and consume more energy.
Wow.
So
Gosh, it's
it's
cool.
so it's a really really large digital load bank that generates money.
Mm. And so with the AI piece, how does that work? So if you've got a vessel floating somewhere that it is its own remote power production unit, and I understand how you could run that through a generator and power some ASICs that are then, connected via internet to the Bitcoin network.
Mhm.
But if you're supplying hash rate to the AI industry, is that also simply done over an internet connection? Like, how does that actually work? And are they are they
So
are they complementary to each other?
it's, I guess, defining the part of the market that we're servicing. So we're not doing
Okay.
like in a regional DC, you can't do low latency inference for a mega city, hundreds of kilometers away. That's not the right market. So what we would be looking at targeting is the large language model learning. It's lots and lots of repetitive processes for a set amount of time, and then transferring that information as a bulk back to the customer. So
Okay.
the location and the latency is not such a significant, I guess, factor in the value mix. And then also your data centers that are not time priority stuff. So you can have some cloud hosting, some data storage services, a real mix of data center, I guess, function. But where we tap in and where we locate the subsea telecommunication cable really defines what market we fit in. Because let's say, for example, Fiji, if we're able to deploy and we're off the coast of Suva, well, we would be able to put low latency inference to the Suva. The city of Suva, that's a perfect target, low latency, great location. But we wouldn't be trying to supply Western Australia. So, it's I guess that's my kind of simple breakdown is that each location is going to have a best market fit, and we just tier our efforts towards getting the right customers.
Cool. And what I love about an explanation like that is entrepreneurs are working on the edges of possibility, taking an idea to actual like execution and fruition is really, really hard. But obviously, through that process, people become extraordinarily expert in their space. And of course, what you're really describing here is
Mm.
what are the different market opportunities that exist for revenue generation. And it's just really about getting your head around what
Yeah.
all those different markets are and being like, well, what price do we need to be at to make sense and which one would function better for what we can do. And hence your point at the very start, which is basically the demand for compute infrastructure is absolutely booming.
Yeah. Yeah.
Wow.
And it's
And I
one of
know,
those,
Sam, that you've...
it's
Please carry on.
yeah. Sorry, Jack, I'll keep going on that one because that it's a really interesting mix of kind of finding in the Pacific region. You've got small land mass with a huge water economic zone, and so these small island nations are actually able to utilize their abundant energy resource, and they can actually become a player in the data center world without sacrificing available land or having to develop out more energy infrastructure on stressed grids. It's a solution. Yeah, it's bringing a technology and a revenue stream to an economic zone that is not really feasible in any other form at this stage.
Yeah, wow. And so, Sam, so what are like what does in your wildest dreams, what does success look like for this?
Uh, wildest dreams. So we we've taken a pretty straight approach to what we want to do, and we want to build ships quickly. We want to do it properly, sustainably, and we want to bring value to the data and the renewable energy world. So success would be seeing that we go from our first class, which is a 25 megawatt vessel, to our 50 megawatt vessel, which right now is technically feasible, but it's a big ask for a first project. 25 megawatts is a bit more palatable, and then actually keep going, get to that 100 megawatt space, because there there are there are quite a few groups who are designing and developing and conceptualizing around ocean thermal as a resource to use as a backbone of marine development. And we want OceanBit to be a part of that. Like we think this is a chance to be deploying ships across the equator. This is thousands of megawatts of resource available, and we want to be there. We want to be part of the story that is like, well, yeah, okay. So ocean thermal, it was a pretty hard run for it for a while, but in the 20s, we actually saw the first real commercial developments kick off, and it'd be incredible that OceanBit is front and center of that discussion.
Mm. Really cool. And because we talked about this before, Sam, on a couple of the calls that we've had and stuff. But as you know, I used to be a shipbroker, and so for whatever it
Mm.
was, 7 or 8 years of my career, every day I was speaking to ship owners, and in my particular niche, I was focused on dry bulk commodities, so iron ore, coal, grain, sand, cement. Um, at the end of the day, those businesses they're run by shipping professionals. They understand how to move shit from A to B in extremely hostile terrains. I mean, 150,000 tons of iron ore on a ship is a seriously big deal. But what strikes
Yeah.
me as true is, at the end of the day, they had a big industry of people who were, either asset managers, and they're looking at assets and thinking about yields and thinking about depreciation over time, and they're looking at, there's a huge secondhand sales market for different ships, and that market is as volatile as any market I've ever seen, frankly. Um, there must be people out there in the shipping industry that would be forward thinking enough to look at this concept and think, actually, that's a yield play. If I put X, I can go to a shipyard and I can go and build these things, and I can then deploy them, and I can make a yield out of them as a shipping business. Have you had any conversations with people along those lines? And yeah, just intrigued as to who you might think would be the kind of player that would really get behind this.
Yeah, so definitely have spoken to quite a few different folk in the marine industry, and a good reference to the dry bulk fleet. I started my career on a 160,000 ton iron ore carrier, so
Oh
I
shit.
was I
Yeah,
was
wow.
sailing across yeah, sailing across Southeast Asia and around Australia on one of those big luggers.
No
But
way. Yeah, they're massive.
yeah,
I
look,
went on one in Singapore.
it's
It's
a really
crazy how big it
interesting.
is.
Yeah, yeah, no, it is. It is. They're intimidating in their size. You can go through rough seas and you can see the bow of the ship moving before where you're standing moves. There's a lot of flexibility, but and a little bit of stress. But no, look, the conversation. I guess that's where we flick back to, okay, well, where are we in this journey as entrepreneurs and trying to develop this concept? And so we've spoken to quite a few parties. The general response is, this is incredible. Wow, you guys have a really amazing concept. We would like to see you do a little bit more. And so it's, and that's fair, because you're exactly right. They're looking at yield, they're looking at their returns and their balance sheet and their investors, and these companies don't have free reign to just throw money out to a good idea. But I think where we are in our path is that we're now getting towards the position where we're no longer a good idea. We are getting towards project development, which means, okay, all of a sudden it's not just a concept. We're working through the feasibility of locations. We're getting licenses and approvals and the strategy of the deployment and the operation planning, and so I feel like we're at the cusp of transitioning into the project phase, which suddenly changes the dynamic of how these entities look at us. And the thing is, like, so in the marine world, there's giant entities. They are all, forward thinking. They have to be paying attention to the global trends. They have to be aware of where the opinion on emissions from shipping sits on a global scale, where the international regulations going, all those kinds of things. So I think once we flip over into the project phase, that we suddenly become a solution to a renewable energy or sustainable development pocket of these larger operators that they're all trying to bring into their mix.
Yeah, cool. It strikes me actually as
Mm.
well that it's not dissimilar to people trying to build Bitcoin mines on flare gas. And like I've
Mm.
got a number of people I know here in Australia that have been involved in Bitcoin mining projects of different forms. And it's one of those things, on paper, it makes a lot of sense, right? You're already burning this shit. If you could harness that power, run it through a generator, you could get paid not only by the Bitcoin network, but also the carbon credit system that exists. So
Yeah.
the sell is quite strong, but equally, you go to an oil and gas company, these guys get oil and gas out of the ground and sell it. And if you're like, hey, we're a Bitcoin startup and we want to make money off your flared gas, they're like, what? Bitcoin? What are you talking about? Get out, you know? And hence, when you
No, and
introduce
that's
yourself at the very
yeah,
start, you
100% right.
mentioned
It's I
data
guess
centers.
yeah, and actually yeah. So we're going to have a little bit of a delay in that conversation there. You got to love remote hosting. But yeah, no, exactly the same. You know, you turn up to a group that are oil and gas, right? So I think it over in the States, they had a couple of refineries, oil and gas, industrial sites, right? You know, I'm not I'm being the generalist again, but some of these sites actually had to shut down, right? They would hit their cap of emissions, their yearly cap of emissions, and then up comes a Bitcoin mine that comes on. The way that they process the emissions was, I think they were burning the methane, or whatever the output was. They were able to convert that into energy, mine it, and the output was a lower rated emission. So the refinery or the industry could keep going for 12 months and not actually have to shut down due to those kind of legal restrictions on operation. So like that's phenomenal. Yet you go to another location in the world and you use that as an example, and I know it's still very new, and that doesn't fit into our risk profile. And it goes back to that these large entities are they've got their security and their risk management in place, and so until we can be an independent deployed example, a lot of the conversations kind of come up. I know, look, we won't consider this until we can really see it, and that's just kind of part of the hustle of being a startup and trying to do something new. There are entities and there are individuals and there are groups out there who take that punt and try and push the edge, but it's not everyone. And so it's one of those things of, well, the great saying of you buy Bitcoin at the price you deserve. And so if it doesn't fit your risk palette right now, that's okay. You can hang tight and wait for it to be, smack bang in your risk management, and off you go.
This is something I also noticed, and this is why I think it's important to be doing Bitcoin podcasts, or just podcasts in general. You may have also been on some like renewable energy ones. I'm not sure because I hadn't seen that myself, but it's all about finding gatekeepers. So like you're very confident at this stage that you could build something absolutely epic, and hence you've literally dedicated any spare time you've had for a number of years towards building this thing. And that's epic. That's as good a signal as you could give anyone that this is really worth my time. You should pay attention. And so there'll be people out there that are sitting inside big companies that are also doing their own research and thinking about things differently. And it's about somehow connecting with them. And I think podcasts are a great way of doing that, because like you don't know who's listening, right? There might be a few thousand people that suddenly listen to this episode and are like, oh, do you remember that thing? And do you know what I mean? And they go and talk to their boss about it, and then you might get an email, and you've probably had contacts like this.
Well, I called Nate.
Yeah, well, that's how you got
because
involved.
of a podcast.
Yeah, wow. Yeah, cool.
So
it's so true.
Yeah, no, it is. It's a really powerful tool of kind of just getting the idea and the conversation out there.
Well, Sam, I wrap these up at 60 minutes, in spite of the fact that basically every single guest I could talk for longer with. Apologies for the delayed Wi-Fi and stuff on my end. I'm sorry about that. But my final question is, if people want to reach out and get in touch, what's the best way to do that?
So we've got a website, oceanbitenergy.com. So there's a little contact us link.
Cool.
And I guess the other way is I'll throw my email down in the show notes.
Awesome. Sam, thank you so much for your time today.
Thanks, Jake. It's always good catching up, and hopefully the next time we do it in person.
I need to build a studio. That's a big plan. Thank you, mate.
Done. And we'll bring Nate. We'll bring Nate for the studio version.
Oh, that would be awesome. Yes, please. And shout out to Nate. I hope you're really well, mate. Thank you, Sam.
Thanks, Jake.